So we are going to learn something about isotopes. We already know what isotopes are. We will do some questions on isotopes in this video. So isotopes, before we go further, we will learn, we'll just revise on what are isotopes. Isotopes, we know that an element hydrogen has got one proton, one electron and no neutron. But there is other hydrogens also which has got an extra neutron, but the number of proton is the same, and there are two more hydrogens which has one neutron and two neutrons, and these are called as hydrogen, deuterium and tritium. And these elements that have same number of protons and different number of neutrons are called as isotopes. Calculate the average atomic mass of chlorine with the data given in the table below. So the data given is, we have the percentage abundance of the two isotopes, 35 and 37 of chlorine, and the relative mass is also given. So atomic mass of chlorine will be equal to, you take the relative mass and multiply it by the percentage abundance, and see there I have divided the percentage abundance by 100 and then add it up. So when I add it up and calculate the value, I get the atomic mass of chlorine as 35.4528. The two isotopes of boron are boron 10. The percentage abundance and the relative mass is given, and for the boron 11 also the percentage abundance and the mass is given. You have to calculate the average atomic mass of boron. The question is similar to the one which we did before. The atomic mass will be multiply the percentage abundance by the atomic mass given and calculate the average atomic mass, and that comes as 10.811. So the next question is, an element has three isotopes. Find the average atomic mass and identify the element from the periodic table. So in the table, the percentage abundance is given, relative mass is given. This is nothing different. It is similar to the same question given before. Use the formula, calculate the atomic mass, and then the only difference is here we have three isotopes. So after you calculate the isotope, just refer to the periodic table and find out what the element is. And when you get the atomic mass as 238 and look at the periodic table, you will realize that this element is uranium. Calculate the natural abundance of the rubidium isotopes. The mass is given and the average atomic mass of rubidium is also given. Therefore, this is a different kind of a question where they are asking you to calculate the percentage of abundance. So in order to do so, let's assume that the percentage abundance of one of the isotope, that is say 85 rubidium, be X. Since the percentage abundance, the total has to be 100. The other isotope, the percentage abundance will be 100 minus X. So now the whole question becomes simple. I have the percentage abundance as X and 100 minus X. Substitute it into the equation which we normally use, and then solve for X. And just be careful while you are solving for X. In order to remove the 100 from the right hand side, easier way to do is multiply the whole equation by 100. Therefore, the 100 goes to the left hand side and the right hand side equation becomes simpler. So this will enable you to solve the question easily. And don't forget, there is a parenthesis in 100 minus X. So the 86.9092 is outside the parenthesis. I'm telling these things because these are the major mistakes generally people do. So practice one or two questions like this, and when you calculate the value of X, and I get X as 72.05, that is the percentage abundance of one of the rubidium isotope. The other isotope can be calculated 100 minus X, and that comes as 27.95. Calculate the natural abundance of rubidium isotopes. The average atomic mass is given. The average atomic mass of rubidium is also given. So you must be wondering, this is the same question as we did before. But I'm just showing you one more method by which the same question can be handled. In the previous case, we assumed the percentage abundance of rubidium 85 to be X and that of rubidium 87 to be 100 minus X. So instead of that, we can also assume let the percentage abundance of rubidium be X and that of rubidium 87 be 1 minus X. So when we substitute all the values and get the value of X, I get X as 0.7205. So what we do here is whatever answer you get here, multiply that by 100 to get the percentage value, and therefore rubidium 84 percentage will be 72.05 and that of rubidium 87 is 27.95. So what is the advantage of this method is assuming it as X and 1 minus X, the calculations become simpler, and so for the solving becomes easier. That's all. But just remember to multiply the final answer by 100. You can do it either way. Whichever way is convenient to you, you can follow. But the answer will be the same. Calculate the atomic mass of silicon-30 using the following data. The data is given. The average atomic mass of silicon is also given. The percentage abundance of 3 silicon isotopes, 28, 29, 30 is given, and the relative mass of 2 of the isotope is given. You have to calculate the relative mass for the third isotope. So just set up the equation. The average atomic mass is abundance times the relative mass, and if the abundance of one of the isotope is X, the last one becomes 0.0309 times X, and get the value of X, and this will be the relative atomic mass of the isotope silicon-30.